Batman and Robin leave the club at the same time. Batman heads north at 40 miles an hour, while Robin travels east at 30 miles an hour. Find an expression for the distance apart d at the end of t hours. So here's our club. Batman leaves going north at 40 miles an hour. Robin leaves in his dumb little motorcycle or boat or whatever he's got. He ends up blowing up all Batman's cars anyways. He never gets anything nice. So we have our two pieces of main information. We have 40 miles north, 30 miles east. And we're looking for this distance. The distance between the Batmobile and Robin's piece of junk. It's distance d. And we have two ways we can go about solving this. We can, as I'm sure you can see, we have a right triangle, so we can use Pythagorean Theorem to solve for this long side. Or what we can do is we can assign this right here a point and this right here a point, and we can use the distance formula. I'm going to solve it with Pythagorean Theorem first, and the reason I'm going to choose Pythagorean Theorem is because I think it's easier, and we'll see why that is. Basically there are just fewer steps to it, so there's less chance of making a mistake. So we're not only looking for the distance, we're looking for an expression, which means we want to get a formula that will describe this distance given any point in time. So if I give 5 hours, or someone gives me 5 hours, I'll be able to put that into a formula and it'll give me the distance. It could be 5 hours, it could be 100 hours, it could be a million hours, or it could be a tenth of an hour. It doesn't matter. That formula will give us their distance for any instance in time, and we're looking for it in t hours. So this is going to be our variable t. So the first thing might be to decide where to put the variable, and in this case it's pretty simple because miles per hour is already essentially a variable. So we have 40 miles for every h hour. So we can essentially replace t and h. We can switch them around, and this will be what we're looking for. But in a more complicated problem sometimes, or if you've never really done them before, perhaps it's not as obvious, but in other variable problems, what I generally like to do is, especially in problems where there are multiple variables, I like to start by finding things that have the same rate of change and that start at the same location. Then we can truly put in a variable and they'll be the same. So here they both start at the club, so time starts at the same location. Time is 0 right here, and then time changes equally in this direction as it does in this direction. An hour for Batman is an hour for Robin. So that's how generally I like to approach variable problems when there are word problems, when you have to assign variables. But there really isn't a set way of going about it. It's a lot of intuition, a lot of it's just seeing a lot of problems. So if you have trouble with them, don't be too worried, especially if you haven't done a lot of them. They really just take time and practice. But let's go ahead and use Pythagorean Theorem to solve this problem. So there's Pythagorean Theorem. Now we'll just plug in the sides. And remember, we replaced miles an hour with t, 40t and 30t. So these are going to be our two sides. So 40t squared plus 30t squared is equal to d squared That gives us 1600t squared plus 900t squared is equal to d squared. That gives us 2500t squared is equal to d squared. And now we take the square root, and that leaves us with d is equal to 50t. And this is the expression that we're looking for. So over here, this distance at any given point in time is equal to 50t. And the good thing about these kind of problems with the distance formula and using Pythagorean theorem is we can check our answers. So let's do a really simple one. Let's just say 2 hours have passed. 2 hours. So our north side, where Batman's going, 40t is 40t, so we replace t with 2. So that gives us 80. So he's gone 80 miles. And Robin is 30t, so 30 times 2, which is equal to 60 miles. And then our formula is 50t. So 50 times 2, and that's equal to 100 miles. So according to our formula, they should be 100 miles apart after 2 hours. So what we can do is just put this into Pythagorean theorem, and if our equation is correct, we should get the same thing on both sides. So they'll be equal to each other. So let's do that. Well, let me draw the triangle just to make sure everyone can see what I'm talking about. So we got that this side was 100 from our equation, and we know this side is 80. It's 40 miles, 40 miles an hour in 2 hours is 80. And 30 miles an hour in 2 hours, that's 60. So this is our triangle. So again, we can use Pythagorean theorem to check our answer. So we have 80 squared plus 60 squared is equal to 100 squared. 80 times 80, that's 6,400, plus 60 times 60, that's 3,600, plus 100 times 100, or is equal to 100 times 100, and that's 10,000. And yeah, this is a 3, not a 5. So we add 6,400 plus 3,600, that's 10,000. So 10,000 is equal to 10,000. And that's how we know that our formula worked and that we got a right answer. So now that we figured this out using Pythagorean theorem, let's use the distance formula. And it's really the same thing because we get the distance formula from Pythagorean theorem. So if we know that, we know we should get the same answer. X2 minus X1, Y2 minus Y1. So here we are, and let's rewrite the graph. So start with the club, go north, this is 40t, east, this is 30t. So the main difference here is that we need to assign points. And we can do that. We can assign a point here, we can assign a point here, we can assign a point here, and get this distance here. So in order to assign points, we can just use any points we want, really. But whenever you can, you should definitely probably use 0, 0. So in this case, we can use this point as the starting point. We'll say it's 0, 0. But again, it doesn't matter. We can do 5, 5, 100, 100, 10, 37 and a half. Doesn't matter. But in general, if you can use 0, 0, you'll definitely want to do it. It just makes the math work out a lot easier. So now we need to assign a point here and here. Let me start with this one. So we'll say that this is the x-axis. So this point would be at 30x, but we need to add our t on the end, and it's at 0y. And this point here, this is the y-axis, so it's at 0x 40y. 0x 40y, and we add the t on the end. So now we have our points. We can say this is point 1 and this is point 2. But again, it doesn't really matter for the distance formula. Any 2 points will give you the same distance. So we'll rewrite it over here. Point 1 is 0, 40t. Point 2 is 30t, 0. And now it's just a matter of plugging these in. So the distance is equal to our x2, which is here, 30t minus our x1, which is 0, plus our y2, which is 0, minus our y1, which is 40t. And both of these are squared. So now you can see how using 0, 0 makes it a lot simpler. Just less work to do. I remember, even though that this is a negative number right here, it's going to be squared when we'll get a positive distance. So that gives us 900t squared. So some of this should start looking familiar. 16t squared. And that is equal to 2500t squared. And that's equal to 50t. So as you can see, we got the same answer, 50t, through the distance formula. And we got 50t here through using the Pythagorean Theorem. Again, we get the distance formula from Pythagorean Theorem, so it's the same thing. But as you can see, I'm pretty sure the Pythagorean Theorem required a lot less work. In this particular example, there might be examples where they give you the information in the form of ordered pairs, and in that case it would probably be easier to do the distance formula. But more often than not, the Pythagorean Theorem will be the one with less work. And it's not necessarily that one's more difficult than the other, it's just when you're using the distance formula there's more work to be done, there's therefore a greater opportunity to make a mistake. And in math, there are usually multiple ways of solving a problem. So you want to generally pick, well, you want to pick the one you're most comfortable with, but then after that you want to pick the one that requires the least amount of work. Anytime you can minimize the amount of calculations, you should probably do it.